Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 100. Check if two binary trees are the same tree. In this video, we're going to share a solution based on recursion. First, I'll read through the problem statement to digest the requirements, and then we look at the examples quickly, and finally we share the code. So first, let's look at the problem statement. Given the roots of two binary trees, P and Q, write a function to check if they are the same or not. So the next paragraph defines what do we mean by the two trees are the same. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. So here are three examples. So in the first example, you can use your intuition to see how they are the same, right? Is the structure the same? And in the second example, so they are not the same. The values are the same. However, so 2 is the left subtree in the first first tree, and 2 is the right subtree in the second tree, right? So their structures are different, so we return false. So in example 3, so we notice that so the left subtree and this one has a value 2 and this one has a value 1. So and this has a 2 and this has a 1. So they are sort of it's a reflection, right? So their structures are different, so we return false. So here the constraints on the nodes, the number of nodes in the tree in both trees is in the range 0 and 100. So it means that the trees can be null, and but they contain at most 100 nodes. So the node's value is in this range. So we can notice that the node value can be positive, can be 0, can be negative, but that's not very essential for us. So with that said, we are ready to write the code. So here, we first let me write here. So we need to first notice that so the binary tree, or in general the tree data structure, so can be defined recursively. So we can term it as a recursive ADT, right? So in this case, so there are some rules of thumb or some experience. So once we meet such problems, so we can think first if we can solve this kind of problems using recursion. So here we're going to use this example to demonstrate that this problem can be solved elegantly using recursion. So first, notice that this assumption, right? So the number node can be 0. Let me write like this: if not P, right? Not P and not Q. So in this case, the two trees are both null, right? So we are going to return true in this case. So this actually also serves as a stop condition or base condition for the recursion. So this is one case. So now let's consider the else block. So if the complement of this is either P or Q, right? At least one of them is not null. Then let's consider this case. If not P, right? Or not Q, right? In other words, one of them is null, but we know that at this else, at least one of them is not null. So we are going to return false in this case, because a null tree and a non-null tree are not the same tree. So now let's look at the else. In this case, both P and Q, right? So now we want to check the things. First, we need that the root value should be the same. That is, P value equals Q value. And then we need their structures are recursively the same. In other words, we need to check the left subtrees of P and Q and the right subtrees, and they should be the same respectively. So we're going to use logical add, right? And so let's do a self call, right? Self is same tree. So P left subtree, Q left subtree, right? And also, so we are going to use self is symmetry P right and Q right, right? So this actually is nothing but a translation of this definition. So this actually forms a solution to this problem. So now let's first do a check. Yeah, it passes the first example. Now let's look at this example. Let's see if we can check that. So copy that. So this should return false. Yeah. So let's also check this one, 121 and 112, right? So this is the false. Now let's look at the generic case. Yeah, it passes all the generic cases. So this is actually a very easy problem, but it's good to think and practice more. So you can, for example, write different solution formats for this same problem to practice. So this is the one way to do the practice of coding problems. Another way is that we solve different problems using the same method or same technique. That's another way. So this way you can do it like this or like that, so that we can gain better experience. So with that said, I guess that's about it for this video.